My name is Angel Nava,
I'm Justin Mariquin.
and we are part of Team Hydra, which is a senior design group at the College of Technology at University of Houston. Our project was centered around designing and manufacturing an ROV. An ROV is an underwater remote operated vehicle. They're typically used in a lot of different applications such as the military and scientific exploration. And they usually take the place of divers in situations where it's too detrimental to human health. Our design was centered around the MADE competition, and we adhere to a lot of those specifications.
So the MADE competition is a competition for schools to compete with their own built and designed ROVs. We compete in different classes such as Scout, Explorer, and Ranger, and we're the Explorer class because we're a university and college team. So pretty much the premise of the competition is to design your ROV, go underwater, and simulate tasks that ROVs would do in the working field today, such as replacing a hot stab, checking the pressure at a certain depth, or replacing a tool.
I'm Ivan Stockton.
Larry Fong.
And we are part of Team Hydra. My part of the project was the control system, which I was tasked to write the programs using LabVIEW and also design the electrical system for the ROV to control the thrusters and the arm using an Xbox controller and a joystick.
I was responsible for mostly the visual systems of the ROV, which is just the camera here. And right now I'm currently running the computational fluid dynamics analysis for the ROV itself. So we're simulating it, simulating its pressure and its the flow as it goes over in the computer.
Another part of the ROV that had to be designed along with the electrical system was the housing. It had to maintain watertight integrity, so it had to be designed to allow wires to come out of it, but also keep water from going in it.
So my part of the whole design project was centered around the project management. I was the team leader, and I did all the analysis on the frame and the design on that. We had to make sure that it'd be able to sustain the loads that we were going to put it under, such as the weight of the housing and the weight of the arm. And we wanted a good design that'd be easy to lift and would be pretty roomy.
For my part of the project, I had the hydraulic system and the arm design. One of the biggest learning curves I had for the project was the hydraulics. I didn't know much about hydraulics coming into the project, so a lot of it was spent learning about that. Just things such as a single acting and double acting cylinder, how they operate, even just the valves to operate the cylinders. So we have like servos and solenoids, learning the difference between those, and choosing the components to work with our housing system because we wanted our hydraulic system to be on board. So the hydraulic pump and the valves that we use to the servos to control the cylinders which motion the arm all fit well within our housing system using our tiered system. So we were able to complete that objective for our design project.
So we learned a lot of things over the course of this year-long project. For me, some of the biggest things were communication, teamwork, making sure you order things on time. There's a lot of lead time for some of these, so if you order something and it takes a long time to get to you, then that sets back your whole project. A lot of some of the engineering applications that we also considered when designing this was buoyancy. So we had to take that into account when considering our housing and our frame design. We had to make sure that we would have enough weight to the ROV that it would sink. Well, we were trying to achieve a thing that's known as neutral buoyancy, and that principle is centered around like knowing the specific weight of the water and the volume that you're displacing overall throughout the whole designs.
But also, besides the design and assembly of the project, it also gives us a good vision to like the whole engineering aspect as a whole. So you have like communication with the sponsors, going to their shops, and keeping just communication between the team and sponsors such as that to make this possible. So for instance, like our arm was sponsored for us, it was manufactured for us, and having to keep communication between them to make sure they were able to do it for us, and actually going to their shop to learn some of the machining experience and get some hands-on experience as well when assembling this project.
One of the greatest things I learned about doing this project was the aspect of reaching out to people to support a project. I guess before this project had started, I was really ambivalent about asking for help because I wasn't really sure about how people would be willing to support a student project. But after reaching out to like sponsors or people who could just donate anything for the project, I realized how much educational value that people hold for these kind of things.
Doing projects like this allows a lot of students that just don't have real world experience in any fields to have to do the research and to learn how to put things together and what doesn't work, because you're going to have failures, you're going to have mistakes, and it teaches you to overcome those mistakes and how to solve problems.